My name is David McPhail. I'm the President and CEO of Memex. We have a booth here at 2617, so 2617. If there's any information that I don't give you here, this is not going to be a product pitch or a product display. It's more thought leadership. So I invite you to go and talk to our salespeople at 2617 if you have any questions specifically regarding the technology. So we're going to talk today about serving the stakeholders, and we're going to talk about specifically as it relates to bringing the IIoT to the factory floor or in manufacturing. This will be the agenda we'll be covering. We'll talk about the data streams, in other words, the fuel to fuel an IIoT implementation in manufacturing. We'll talk about, obviously, stakeholders and situational awareness. We'll go to the factory of the future and production visibility. We'll then go to IoT, OT convergence. So what's the fuss all about? We'll talk about automated OEE, a pragmatic business use case. Roadblocks to adoption, examples of results achieved. We'll have summary, and then we'll have some Q&A at the end. So with that, let's get started. So what data streams do we require to fuel an industrial Internet of Things implementation in manufacturing? Well, maybe we should talk about the reason why to do this in the first place. So connectivity is an essential piece of this. We have to have data from the shop floor, so connectivity is extremely important. Some of the high-level business drivers include higher customer satisfaction, competitive agility, and lower costs. Obviously, everybody wants to lower their costs, and then obviously greater productivity. Everybody wants to try and do more with the same level of effort. I hope to show you how we do that. But where we have customers, suppliers, the enterprise, the shop floor, and management all working together with the same data set. So we have essentially what's called one version of the truth. And again, I'll go into a little bit more detail as we move forward here. This is an example of a hardware device that we manufacture. Said that's not a product pitch, but one of the questions I always get asked is, how do I connect my legacy equipment? If I buy a new piece of equipment, that's great. It comes with an Ethernet jack. We can just plug into it. But how do I connect all the balance of the rest of my equipment? There's about 70% of assets today used in manufacturing are what's called legacy equipment. And so this is just one example. I just bring this up so that, and the slide after this is just some pictures of some of these older controls that we've now brought essentially into the industrial Internet of Things, because now we can take data out of them. So we actually know what they're doing. And before we had the advent of IoT in manufacturing, this was a difficult and expensive exercise. And so what we've done is we've kind of streamlined that now. And there's other people that make hardware adapters for legacy controls. I'm just bringing this up to, because I always get asked this question usually. So another data stream that we need is we need to integrate our business systems, our ERP systems, with what's going on the shop floor. And that's important because we can do things like drive inventory and procurement directly from ERP right down the shop floor, and we can take that data back, and everybody in the organization has the visibility now of where the work order is, as an example, throughout the factory floor. We get the schedule, we can track job progress, and we minimize work in progress. So everybody, when we talk about lean manufacturing and lean manufacturing initiatives, everybody wants to reduce the amount of work in progress that they have, because essentially that's muda or waste. We want to try and get to as close to a just-in-time shipment from an order to a finished part in the shortest time possible. We don't want to have piles of inventory piled up. So that's important. In order to be able to initiate that and to be able to sustain it, we have to have the visibility of what's going on the floor. And then when we talk about IoT in manufacturing, we need to look at all three data streams. So we've talked about two so far. We've talked about data from the ERP system and data from the equipment. But there's a third, and I would argue the most important link in this chain is the operator. The operator needs to be part of the solution. So we have operator data. We already talked about business systems data, and we talked about a little bit about machine data. I did a presentation yesterday on connectivity that will be on the website, and I go into a much more detail than what I'm going to do here. But if we don't have the confluence of these three data streams, then we get reactive and we generate lagging metrics. So if we're calculating OEE as an example, but we're doing it manually, we're actually transcribing that information onto a piece of paper, ultimately aggregating it in a spreadsheet, and then firing it out to management or the stakeholders, and we'll get to those in a minute. It's lagging, and I would argue subjective and chronically inaccurate. When we do have these three data streams working together in IoT, we get proactive alerts, we get real-time data, we get transparency and visibility across the entire enterprise. We'll talk a little bit about the factory of the future here. And how does data-driven manufacturing come alive? Well, we've already talked about the fact that we need to get the data from the equipment. If we don't have the data from the equipment, we have no idea what's going on in the factory floor beyond opinion. We need facts to be able to make proper decisions. We already talked about integrating our ERP system, so we know the production schedule coming. We know when we have other suppliers that are, whether they're doing surface treatment for us or painting or heat treating or whatever, we can give them a heads up. So we can tell them that, look, next week or the end of this week, we're going to send you a batch of parts, and they can be ready for those batch of parts. If we want to get really elegant with data with IoT manufacturing, we can attenuate our high-value tooling and our work in progress with RFID, and actually we can track. Some of our customers make landing gear, very expensive, very long-running parts, and for them to be able to track and with RFID where these parts are, some of them take 50 operations to go from a forging to a finished piece of landing gear. So this is another example of an additional data stream we can use to augment the factory of the future. What's the purpose of doing this? Well, we all want to drive costs out of our enterprise. Our customers are constantly challenging us to reduce our costs. And so when we have the ability we have the 3 data streams that we just talked about, we can actually drive costs because we know where to concentrate our continuous improvement efforts. Process improvement is not a straight line. It's constantly changing. You have 3 things in any factory that are constantly in flux. You have the people. People retire or people leave, and we hire, or we expand and we hire new people. We have the products that we make. So we're constantly looking to expand our business, expand our lines of business, take on new customers, new products. And the third thing that changes in most manufacturing companies is equipment. People buy new equipment, retire old equipment. And so when we have these 3 things constantly in flux, if we don't look at continuous improvement as a circle, 0 to 360, rinse and repeat, we're fooling ourselves, because when one of those 3 things changes, we'll step back into our old habits and we'll not be as productive as we otherwise could be. And then when I talked earlier about having your trusted suppliers be part of the value chain here, we call this horizontal and vertical integration. Horizontal integration right across our enterprise, and vertical integration with our suppliers and our trusted suppliers. When we have the ability to create the factory of the future, horizontal and vertical integration is a definite side benefit. So we're going to talk a little bit about who the stakeholders are. Who has a vested interest in the outcome of a successful IoT implementation in manufacturing? Well, we have obviously an easy one, production. Right? The ERP generates a work order, says the production, okay, go make this part. We have obviously engineering. Engineering creates the drawings and the process by which the parts get manufactured. We have the operators, as I said, a key piece of the puzzle and a key member of the company. And then we have management. And management wants to know that and we'll get into the specifics about management, but management wants to know that everything is progressing the way that it should, that we're going to hit our profitability targets, we're going to hit our revenue generation targets. So we'll talk about production for a minute. Well, obviously production cares about visibility, transparency, operations efficiency, reporting flexibility, the ability to improve income from operations is important to production, shop floor communications, and the biggest one at the bottom, I think, is job status and time to completion. This is what production cares about. We've had customers that tell us that they spend, before they do an IoT implementation like the one we're going to talk about, they spend a lot of time trying to figure out when they're going to ship this part. So somebody has to go down the factory floor and run around and find out where that part's going to be. That all goes away when we have transparency and visibility. What does engineering care about? Well, they care about scalable deployment, enhanced productivity. They care about process efficiency. They want to know that when they constructed a part in Vericut as an example, or Mastercam, and it said that part takes, I don't know, just pick a number, 8 hours to run. They want to know whether it ran in 8 hours or not. Did it run in 8 hours? Did it run in 12 hours? So they can concentrate their program improvement efforts in the right spot. Obviously, engineering cares about continuous improvement and automated e-alerts. If, for example, a part's taking longer to run or a setup's taking longer to do than what's allowed, say it's a 2-hour setup, but you're now 3 hours into setup, we can fire an email out to engineering to say, hey, this person or this job or this whatever, this machine needs a little assistance. Operators, well, operators should be concentrating on operating the equipment, so they care about eliminating errors, but they care about simplicity and the ability to use a system with a couple of mouse clicks rather than having to to write down endless amounts of data on a piece of paper. We had one company that we worked with that this is how they used to calculate OEE. They used to take a whiteboard and at 3:25, if the shift ends at 3:30, the operator would write down all the times that the machine was down. And then somebody would come along and aggregate that into a spreadsheet and fire it off to management. What I'll say about production efficiency is that most companies think they're 65% efficient. The actual real number, and we've done this 150 times, is about 35%. So there's a huge perception reality disconnect between how efficient companies think they actually operate their equipment and their people and what they actually do. And that's because the data is latent and inaccurate. And what does management care about? Well, obviously everybody wants to fast our return on investment. Everybody wants to maximize the capacity utilization of the factory. And again, that's where that whole 65-35 discussion comes in. They want to know that OEE is becoming a big topic, and I'll go into a little bit about overall equipment effectiveness in a minute. They obviously want enterprise visibility. They want to be able to see if they have 2 plants in different parts of the world in different time zones. They want to see what's going on in those factories. And then financial OEE and continuous improvement. What does situational awareness look like in the IoT era? I'll give you a few examples. Oh, it could look like this, or it could look like that, or it could look like this, or that. Those are just examples of our product, but now we have dashboards where we have transparency and visibility. What's the value of production visibility? So we'll talk about the how of how to do the factory of the future now. So involve and empower the operator. I can't stress that enough. It's important to make the operator part of the ability to solve a problem rather than just simply pointing out that one exists. Initiate and sustain a culture of teamwork. This is extremely important. When we have one version of the truth, there is no opinion. There's fact and fact only. And so when we set goals and we benchmark those goals, we can actually, as a team within the company, actually achieve those goals collectively together, where everybody has a part to play. And then we move those goals upward over time. And then connects, this is important as well. If we now have the ability to connect our ERP system with what's going on in the factory floor bidirectionally, we get all those transformational benefits, and they're available to everybody in real time. So the when. On average, implementations like this generate somewhere between 10 and 50% productivity improvement. So the return on investment or income from operations increase is usually measured in months at this point. Using a proven solution or with management setting the course for systemic cultural change, which is really important. One of the largest impediments to adoption of this technology isn't that the technology doesn't exist or it doesn't work or it doesn't create the return on investment. The largest impediment is changing the culture of the company. And we find that sometimes slows down implementations, or people don't get the benefits that they thought they were going to get initially, because there really is a culture shift that has to happen for this technology to be properly harnessed and utilized. And then if you believe my 300% internal return rate, or approximately 10 to 50% productivity increase, for every month or 2 months or 6 months or quarter or whatever that this isn't done, this is leaving money on the table. If I generate a 300% internal return rate of capital or a 4-month payback, and we started when your fiscal year started, we would have redeployed that capital 3 times in the same 12 months. So what does production visibility look like on the factory floor? Well, this particular example here is a factory in Florence, Kentucky. It's actually Mazak's factory, and this is an example of an automated cell with a dashboard. You will get somewhere between 6 to 10% of productivity increase if you don't do anything with the data and just put up Andon screens on the factory floor. I can't explain it other than the psychology of nobody wants to be looked at as a laggard. Everybody wants to do their job and do their job well, and so you'll get 6 to 10% productivity increase just by giving the operators transparency and visibility of the production process. And then obviously increasing operator awareness. So the operators can actually see what's going on, and they can actually see when they're making a positive impact to production. Everybody feels good. So Gemba boards and Andon screens. Who here has Gemba boards on their factory floor, where they put the metrics up and people can see them, right? It's pretty common. When you put Gemba boards in Andon screens, we can do them electronically now. They're up to date and they're relevant and they're accurate. And it's also transparent, so everybody can see what's going on immediately. Essentially, also common and objective data right across the entire factory. That's important. And then again, as I said, 6 to 10% by just putting up an Andon screen. This is an example of a customer of ours. This is the operations manager's office. He's got 3 screens, and this is how he operates his entire factory. They have 30 machines. So they live by this data. And when a bubble on that screen to your right is red, and it's red for a sustainable period of time, he's actually out on the factory floor inquiring what's going on. So what's all the fuss about with respect to IoT and Industry 4.0? Well, this you can read the newspaper or online blogs, whatever, and there's a different stat that comes out every week about the value of the transformative value of this technology applied to manufacturing. I like this stat because it talks about a global economic shift of about 2/3 of the world's output. And this was done by Accenture and Cisco. That said, it doesn't matter about the numbers, 6 trillion, 10 trillion, I don't really care what the number is. It's a big number, right? It's a lot of zeros by the future adoption of this technology in manufacturing. Industry 4.0. So I'm not going to go through the first 3 industrial revolutions because I was only around for part of the 3rd one. So the 2nd one, everybody else here probably wasn't around for number 1 or number 2. But where we are right now is we have IoT, Industry 4.0, and IoT convergence happening. And I'll explain what that is in a minute. One of the questions I get asked a lot from senior executives is, I've been told that I have to do this IoT thing or this IIoT thing. How do I monetize it? What does that exactly mean? How does it impact my business? And so this is an example of IoT. So we have manufacturers can take huge advantage of this technology. It's available today. A competitive advantage comes from the machine-to-machine connectivity. So we have that transparency and visibility that we've been talking about. And connecting our machines to create actionable, real-time, accurate data. So again, this is the 3 data streams that we have. We have data from the equipment, whether it's electronic or hardware, data to and from ERP, and the operator portal. This is an example of a business use case in IoT. So we're going to talk a little bit about OEE in a minute, but we could have financial OEE, we could have OSHA work envelope compliance. I think Neil's going to talk a little bit about that in his presentation. Shop floor to top floor connectivity and the connected manufacturing model. These are all examples of IoT in manufacturing or applied to manufacturing. So we're at a connected manufacturing revolution here. Computing started on the far left. But where we are right now is where the business runs on the network and a universal machine connectivity model, okay? Where we choose to call this data-driven manufacturing rather than IoT, because I think people understand data-driven manufacturing a lot better, or that term a lot better than they do the industrial Internet of Things. What exactly does that mean? Data-driven manufacturing means exactly what it implies. So I'd like you to think about IoT, and Industry 4.0, and think about a convergence of those 3 ideas into one strategy called data-driven manufacturing. So IoT was coined in 1999 by MIT. Industry 4.0 was by the German government around 2010. IIoT, or Industrial Internet of Things, I couldn't find a stat because Cisco and GE said they invented it around the same time. So I don't really know who invented the term, but when you think about a convergence of these 3 ideas into one strategy, where we have consolidated reporting, big data and analytics, we have corporate dashboards, but it's all driven by real-time data. I'd like you to think of these concepts all converge together into data-driven manufacturing, or DDM. I know we don't need another acronym in this business, but data-driven manufacturing is what we choose to call it. I want to also talk now about a little bit of myth and reality when it comes to data-driven manufacturing applied in manufacturing. So we'll talk about the myths first. Well, there's a myth. It's a myth. It's a theoretical construct or an unquantifiable capital expenditure with no clear payback, or a highly technical deployment strategy that IT just goes on for ever and ever. And the one I think that's the most important here, the myth, is it's also not a magic bullet for every single manufacturing problem that exists. Well, what's the reality in data-driven manufacturing applied to manufacturing? Well, it's both disruptive and transformative in a good way. It's a known and quantifiable payback. It's practically proven to eradicate productivity gaps. So everybody's trying to do more with less or the same level of effort. And it generates on average about a 300% internal return rate of capital, or about a 4-month payback, and it's available today. I want to talk a little bit about IT and OT and what has to happen for these two groups to work together. So information technology and operational technology. So if you look at what IT and OT are responsible for, or what their concerns are, IT cares obviously about physical risks and safety and security. They care about outdated custom systems, and they care about the scope of impact of a project like this. What does OT care about? Well, they care about physical risks and safety too. They don't want to have a data breach. Nobody wants to shut the company down for those types of reasons. They care about productivity and quality control. And the biggest concern they have is working with IT. So these two camps don't cooperate very well together. Here's what has to happen for these types of technologies to take hold in manufacturing. So when we look at what IT cares about. Well, they care about the ERP system. They care about the networks. They care about obviously email and all the databases. That's what concerns them. But here's what OT cares about. They care about the ability to take data from the factory floor. They care about the ability to transfer programs. If you're a CNC shop and you need to transfer programs back and forth, that's a vital piece of software for OT. And then they care about all the applications that sit at that layer there. Here's what has to happen. There has to be some common ground. There has to be a meeting of the minds. We have to be able to do this in a secure way, and Neil in his presentation will go through some examples of that. We have the ability now to encrypt all the communication, so we can actually take data that's encrypted both at rest and in flight. We obviously want the integrity of the data that's generated from these systems, and we want to know that the data is accurate and that it's secure. That's the convergence of these two teams has to happen, and we're starting to see a little bit of that. We're starting to see some IT and OT convergence together, but there's still a long way to go. I'll talk about the benefits of overall equipment effectiveness. Who here tracks or understands OEE or tracks OEE manually? All right. Sometimes I get no hands up. It's good to see at least 2 or 3 hands up. What are the critical business challenges? Well, everybody wants reduce their costs, rising business costs, labor goes up, equipment goes up, material goes up, but the customer doesn't want to pay, your customer doesn't want to pay for it. So productivity and asset utilization maximization, obviously the accuracy of the data is extremely important, because if we have bad data, we make bad decisions. So why does OEE matter in the IoT era? Well, it's one of the most important metrics in manufacturing. We're able to now finally distill the efficiency of any production process into a number. And we'll get to what the numbers mean in a minute, but world-class is 85%, which is 95% in each of the 3 categories across the top: availability, quality, and performance. So we look at OEE itself. Availability is simply runtime divided by total time, which includes downtime. Quality is an easy one too. It's total parts good parts divided by total parts, which includes rejects. And then performance is, does the machine run at rate? Are we actually producing parts? When we say we're going to make a part every 5 minutes, are we making that part in 5 minutes? Are we making it in 8 minutes? Are we making it in 6 minutes? That's your performance metrics. The combination of all 3 multiplied by each other is the gold standard in manufacturing, is becoming the gold standard in manufacturing. What drives the desire for OEE? Well, first of all, as I said earlier, we're replacing this subjective data collection with objective data collection, so we have one version of the truth. We say this, it's like shining a light on dark assets. So we have a factory that's essentially dark. We don't know what's going on. We can't see it. We connect everything, and actually we can see what's going on the factory floor, how efficiently we're producing our products. The continuous improvement programs are always better when they're fed with real-time data. When you look at a Kaizen event as an example, when the first day or day and a half you spend collecting data, the next day you spend coming up with a project to improve the process, and the last day or half a day you spend collecting data to see whether that change was positive, neutral, or negative, and then you rinse and repeat. If we have everything connected and we're calculating OEE in real time, all we have to do is run a report and then pick the continuous improvement areas that we want to work on that have the highest value, and we prioritize those based on value contribution. And we say reveal your hidden factory. As I said earlier, Most companies think they're 60 to 65% efficient. The actual number is sub 35%. So there's a huge opportunity just to strip out the inefficiency that exists without having to do a lot of special things or difficult things. What's some of the roadblocks that we see? Well, when we went to market, we started going to market with our technology back about 10 years ago. We used to spend a lot of time on the how. So we would spend a lot of time telling people how quick and how much data we could collect and all the stuff that goes along with the implementation piece. We'd spend a little bit less time on the what, a little bit less on the when, and we'd spend the least amount of time on the why. And although that was great and made us feel real smart because we're good at what we do, it didn't really get us translate into a high level of adoption. So now, about 2 years ago, I changed our business strategy to say, let's talk about the why first, because if the why is not understood, the how is irrelevant. If we can't get the customer to vision a post-implementation landscape where they actually can see themselves reaping the benefits, then the project will never get funded, right? Management won't sign off on it, won't release the capital. So the why is the most important question that has to be answered first. I mean, why do this? Why go down this road? Because you're going to ask that question when you go to management and say, can you sign on my capital appropriation request? They're going to ask you, well, why are we doing this? What's the benefits to the company? You have to be able to quantify those in dollars and cents. So some issues to consider. Obviously, focus on the business case, competitive advantage, culture of the company. That's a big one, and change management. That's that most of the time gets understated. The culture of the company is what determines whether this type of a project like this is successful or not. It isn't the quality of the technology or the ability for the technology to do all kinds of special things. The culture of the company is probably the most important thing in harnessing the benefits. And too busy with tyranny of the immediate. These are issues to consider when you're thinking about going down this path. I want to talk a little bit about fear, uncertainty, and doubt. Fear of failure, fear of data system security, fear of the unknown, and fear of change. These are typical fears that we see when people are deciding whether to embark on this journey or not. Uncertainty. I'm uncertain of the path forward, and I'm uncertain that these results that have been promised are actually going to apply to me. And then the doubt about the promised business outcome, and doubt about the cultural change required to embrace this technology. These are all fear, uncertainty, and doubt that we see in our business when we talk to customers or prospective customers. What happens when we add up the doubt, the fear, the uncertainty, and the doubt, we end up with what we call the analysis paralysis problem. Because if we have inaction, endless delay, and more importantly, we have lost opportunity cost. Because if the value equation that I mentioned of 300% or a 4-month payback, companies don't take advantage of that, and they wait 6 months, a year. In some cases, we have some sales cycles that have gone on for 3 years now, where people are just getting around to doing this. How much money was that was left on the table for the 3 years that it took to make the decision? So I'll briefly go through some results achieved post-implementation of data-driven manufacturing. The factory on the left is what I said, a typical factory when we start. The productive time is sub 40%, and then we have, in this case, we have five of the big losses represented in various percentages. But our desired state is the factory on the right. We want to have our production time above 80%. We want to have our OE above 80%. We want to minimize all these small impacts that add up to be big numbers. And they are really small. There's no one magic bullet. When we look at what the value proposition is in all of these different buckets, this is typically what we see. Root cause analysis, obviously reducing downtime, operator productivity increase. Very small numbers, but they add up to somewhere between a 10 and 50% productivity increase. And every one of these are just little buckets, or little small things, little small micro changes that got made that add up to a really big number. Some of the successes that we've seen with our customers, precision machining, 25%. I'm not going to read all these numbers. This presentation is being recorded. And if anybody wants a copy of it, I'm happy to give it to you. But aerospace company, 25% overall improvement. Fine-tuning the setup process went from 410 parts a week to 690 parts a week. It's a 68% gain. I could have 1,000 stats on here, and if you looked at your manufacturing operations, chances are some of these will apply to you, and there'll probably be some that will be completely different. This might be your reality. One of these boxes here. I could have a dozen slides of these. It just depends on your manufacturing operation, the parts you make, the type of equipment that you use. But it is a common theme. From a summary perspective, the path is known and proven today. The why should always be part of the discussion. Data security is extremely important. Data can be collected from all manufacturing assets. It doesn't apply to one particular genre of manufacturing equipment. It can be anything making anything. And there's a direct link between increased productivity and increased profitability. With that, I'll take some questions if anybody has any. Can be either used in a production environment or a job shop environment, either one. So you can look at companies making one of something, or companies making 10,000, or anything from a job shop to auto parts manufacturing, where it's high value, high volume. So when you bid a job, you have an allowance for setup time, right? You say, okay, I'm going to charge the customer 2 hours for setup time, whatever the numbers are. It would be nice to know whether you actually achieved that 2 hour number, or whether you exceeded that 2 hour number, or whether it only took an hour to set it up, because you can be more competitive if you know. And so one of the downtime reasons that we would collect would be setup time, when we're in setup and when we're not. And if you had setup time that was, say your threshold was 2 hours, and you wanted to know at 2 hours and 1 minute, somebody in your organization would have got an email that says you're still in setup time, it's been 2 hours. So you have that transparency and that visibility to, there might be a valid reason why you're in setup for 2 hours. Maybe it's a complicated setup. You can bring engineering staff to triage the problem, but you know, because you know about it, because you know that you've eclipsed your 2 hour window, or whatever the numbers are. Please. So I'm going to leave that question for the next presentation, because that gentleman there, Neil, is going to go in that in detail. I did a little bit of that yesterday. I tried to make the presentation slightly different, but have you heard of MT Connect? Because if you haven't, you will shortly. Right? Anybody else? Hey, well, thank you for your time.